Piecewise function. So the general form of a piecewise function is you have a function with different expressions to evaluate your function. So the absolute value is an example of a piecewise function. So the definition of your absolute value function is that when you have your x a positive number or zero, then the value of your function is x. But if your number, your x is a negative number, then the value of your y is the negative of x. So this is just an example, but in general, a piecewise function is a function composed of several subfunctions. So you have different functions, okay, but it would be you are going to evaluate f of 1 using this subfunction on the conditions of the x that are indicated, okay, on the respective in on the respective values of x. This x should be disjoint, means they don't overlap with each other. Like in this case, we have here x for, if I draw the real number line, you're going to use the first expression. Let's call this f of sub 1 of x, which is x. This will be used for 0 when x is 0 to positive infinity. And then you're going to use the second sub function f2 of x, which is negative x, when your x is less than 0. So I'm still going to include this, but I'm going to use an unshaded circle. So 0 is not included, but all the numbers less than 0, we're going to use this. So that's what we mean by this general form. Okay, so here an example of a piecewise function. This is your first subfunction. So f1 of x here is a linear function. So we're going to use this function when our x is less than or equal to 1. So that means for all this value of x, we're going to evaluate the function, okay, using this first subinterval. So we know that since a linear function, this is a line, I'm just going to pick 2 points here. So I'm going to pick -1 and -2 for your x and evaluate or look for the values of y. So here I have the 2 points, -1, 4, -4, and -2, -5, and then we have a line representing this first sub function. Okay. The green graph is the second sub function. So the second sub function there is 2x squared minus x plus 1. So that means we have a quadratic function. Since this is a positive a, so your quadratic function, you have a parabola opening upward. So it's important to get the vertex of the parabola. Okay, so to look for the vertex of the parabola, we need the x and y value. So the x is given by negative b over 2a. So if I use the substitution to substitute the value, so -1, okay, negative of -1, so that's 1 over 4. So we can simply substitute the value of x to the x variable here, 1/4, so that we'll be able to get the value of our vertex. No? So it's nice to know the vertex of the parabola. And then you may add more points. No? So like what I did here, since our the x for this second subfunction will be from 0, -1 to positive infinity, I'll be assigning values, no, starting at -1. Okay, it's important to start at -1. Okay, and then I'm going to plot the points. You see here the points, and then you can just draw your parabola. But take note the difference, no? This one here is not shaded because -1 is not part of the domain of the quadratic function. So if you look at the arrow here, there is no equality. Hence, we have here a unshaded circle. So if you look at the graph, the blue and the green one, The domain will be all the real numbers. So since it covers -1 to negative infinity and then -1 to positive infinity. So the domain will be all real numbers. But for the range, it would be negative infinity to -4 for the line. And then this one here, 0.88 is the decimal equivalent of the y value of the vertex. So that's why it's important to get the vertex. No? And then it will continue to increase the y value, hence 0.88 to positive infinity. Okay, next example, we have here a function with three subintervals. So you have your first function, absolute value of x. So our evaluation here, we're going to use the first one if x is less than or equal to -2. So starting at this point to less than. So since we know that the graph of an absolute value is a V shape, wherein this is where your value of absolute value is 0. So that means I know that this will be the part of the graph. So I'll just assign 2 points. Then here we have this 2 points. So this will continue to increase. But look at the point that I am using here. It's hollow because -2 is not included. For the second subfunction, it's just a constant function. So the constant function is just a horizontal line. So if there's no condition, your horizontal line will extend all the way to the left and right. But if you look at the condition here, you're going to only evaluate using this subfunction if x is from -2 to +2. So here, when x is -2, we have this point. And then for the other side, +2, again, if you look at this, there's no equal sign here. So that's why we have a hollow point here. So we have our horizontal line, which represents our constant function. And then for this one, we have our root function. So for this root function, we can start -2 to 3 and just substitute it. So we know that in our root function, it's either half of a parabola opening to the left or right. No? So if there's no condition, actually this is half a parabola opening to the right. But since we have a condition here in our piecewise that it will only start at 2. So we evaluate at 2, and then what we got is you have 2 and 1. So this is shaded because we have x equals to 2. Then you can draw half of the parabola. So for the domain, again, you can see that we cover all the x value from -infinity to positive infinity. But for the range, there is only this one number. If you want, you can also put a curly braces here now. So this is y equals -3. And then we will start here again. So that is 1. And this would, you can also cover all the positive values now using this graph alone. No? So they will have the same range. No? So it's okay that they would both have the same range. So this is the range of our piecewise function. So we have this another piecewise function, but not only graphing, we also have the function evaluation. So look at how we evaluate f of 2. We're going to identify where do we have 2. So if we look at this f of 2, 2 is included in this condition, x is less than 3, right? So we're going to use the second subinterval to evaluate f of 2. So that's 3 times 2, 6. And then for letter B, we're looking for f of -3. Since -3 is part of this first condition, so we're going to use this to evaluate. So 4 minus 9, -5. And then for letter C, we have f of 4. So 4 is greater than 3, so it's just a constant function. So to sketch the graph, we're going to identify the first function is a parabola that opens downward. So this one, you start at -2, okay, and then assign 2 points. So you have a parabola that opens downwards. The second subinterval is just a linear function. So a linear function, we have a line. So how do we sketch the graph? You are just going to, this is for 3x, y equals 3x. So you're going to substitute x with negative 2 and 3. So that's negative 6. And then the y coordinate would be 9. So you're going to plot this. So you have negative 2 and negative 6. And then here we have 3 and 9. So look at the equality here. So shaded. And then for the other one, it's just less than 3. That's why we have a unshaded circle, a hollow one. So connect the 2 points since this second subinterval is just a line. For the last one, again, it's a constant function. So a constant, that means you just have a horizontal line. So starting at 3 and 6, then go all the way to the right. So for the look, no, your domain, your range will be from negative infinity up to, so this is the highest point, no, because this will be constant at 6. So the range here will be from negative infinity, and then it will stop at 9. And then since this is a hollow, so we will be using a parenthesis. Our domain here will be the set of all real numbers.